Good morning. Today I'll critically evaluate the Plan, Do, Study, Act cycle, its core concept, where and how it's used in healthcare, the advantages and disadvantages for patient safety, and an overall verdict on effectiveness. Core concept. PDSA entered healthcare in 1996 through Gerald J. Langley, building upon Edward Deming's 1986 industry-focused design. The PDSA cycle is a structured four-step method: plan, do, study, act for solving problems. In plan stage, you define the issue, analyze it thoroughly to uncover root causes, and design a targeted action plan to address them. The second stage is do, is a small-scale implementation of the plan aimed to achieve the goal. The data are gathered to track progress and cause impact. In the study step, those data are analyzed against the original prediction to judge whether the change addressed the problem. At last, the act stage, decision is made whether to retest or implement the change. In the act phase, teams make adjustments or improvements based on the study findings, then repeat the cycle as needed until the issue is resolved. PDSA is well suited to complex improvement work and ongoing refinement, especially when causes are uncertain and must be surfaced through testing. Used well, it strengthens a facility's safety and security posture, improves efficacy, and reduces risk from protocol non-compliance. The PDSA cycle's primary aim is to speed up and strengthen process within the studied healthcare facility. By using a structured approach to identify problems and their root causes, the method enables focused countermeasures that are tested, measured, and refined over time. Using the PDSA cycle, nurses can introduce evidence-based changes that improve patient care and experience. Further, applying PDSA helps the facility optimize workflows for maximum effectiveness and efficacy, while enhancing overall safety and security. Serial PDSA cycles in ED focused on flow, huddles, and capacity management achieved a no patient waiting in corridors. Across diverse settings, teams use the Plan, Do, Study, Act cycle to design, test, and refine safety interventions in small, rapid iterations before wider rollout. A nurse-led pediatric ICU project applied serial PDSA test, example double-checked prompt standardized labels, bedside checklist to cut medication errors. Simulation-based rapid PDSA cycles shaped an airway management checklist by trialing draft steps, observing performance, and adapting wording and sequencing between runs. Also, dialysis centers used PDSA to strengthen infection control, piloting changes in access care, environmental cleaning, and audit feedback to reduce blood-borne transmission risk. Neonatal units improved central venous catheter safety by iterating bundle elements and monitoring defects over time. A psychiatric inpatient service used PDSA to redesign the medical record system, testing from layouts, alerts, and workflows on the ward, analyzing time to document and error trends, then scaling. In each case, PDSA's structured cycle planned, do, study, act enabled targeted experiments, data-driven learning, and progressive scale-up to improve reliability and patient safety. Advantages. PDSA can foster improvement at both organizational and individual levels. For individuals, especially its step-by-step structure provides a systemic way to work towards goal. Even small everyday aim gains clearer direction and a practical path to achievement. Many leading quality improvement approaches such as the Model for Improvement, Lean, and Six Sigma enabled a version of PDSA to trial changes on a small scale before wider rollout. In implementation science, PDSA likewise serves to tailor implementation tactics to local settings, Notably, implementation science tend to treat PDSA as a method or strategy, whereas improvement science often frames it as intervention itself. Disadvantages and barriers. Successful implementation in healthcare depends on leadership providing adequate staffing, technology, inventory, data registries, and financial support. Implementing PDSA cycle can be undermined by difficulty securing consistent engagement from healthcare professionals, time pressure that limit the ability to run high-quality iterative tests, challenges in meaningfully involving patient in settings and achieving goals. The absence of sustained supportive environment for quality improvement, such as leadership, sponsorship, resource, and quality improvement capability, and unforeseen disruptions, such as COVID-19 pandemic, that abruptly shift priorities, reshape workflows, and interrupt data collection. Critical analysis. PDSA works best when you start up with small, well-run tests before scaling up. Small pilots are easier to control and adjust when early results look good. Yet, a recent review found that fewer than 20% of studies actually used iterative small tests, suggesting big rollouts may not be ideal. Another risk is aiming for an overly large system-wide goal that PDSA isn't designed to deliver. Even so, PDSA remains the strongest theoretical framework for designing quality improvement intervention, making it sensible benchmark for other modules. Good execution is essential, and approaches built on weak or unsteady theory face extra hurdles. At the same time, PDSA isn't a rigid recipe, it should be adapted to fit the local context. PDSA shows strong promise for crafting local solutions to complex improvement and implementation problems and is widely regarded as best practice. Yet, results are inconsistent not because the model is weak, but because there is no single protocol and success depends on context. PDSA works when teams follow the essential, form a clear chains hypothesis, run multiple progressively larger tests, collect and analyze data, and update the hypothesis. In reality, these steps are often skipped, so despite its solid theory, PDSA frequently falters in execution. Overall effectiveness. Used with discipline, PDSA is highly effective engine for safety. It improves process reliability, which often translates to fewer adverse events. Effectiveness falls with token cycles, weak measurement, or thin support. And these are the references. And thank you very much.